I seems like the safer bet, I think, in most cases. I just realized I was looking at the stream here, and it looks like we were having a couple of issues with a little bit of the stream. Hopefully, I fixed that. And so, for our producers behind the scenes, I'd love for them to let me know whether or not we got that solved. But in the meantime, thank you for entertaining me with my silly questions. What I'd like to get into now is kind of your background. So, as people may have guessed, maybe from your name or your accent, you grew up in Greece, and I know you have a master's degree in computer engineering. But I'd love for you to kind of take me through the journey. Where did you start? How did a lot of this go? Because I know you kind of got interested early in conversational AI and some of this pattern matching stuff. So I'd love to understand more about that.
Yeah. I think my interest in computers started when I was in high school. I think I was around 15 years old. My best friend was at the time taking a course in programming outside of school, and I found it interesting. So I started reading about, programming languages, BASIC in particular. And it was coincidental that at the time my uncle was getting into trying to use computers in his business. And he gave me a computer to use at home. So it was an Amstrad CPC 664 that, it had the one block basically that had the integrated keyboard and the floppy disk drive.
Yeah.
And that was a springboard for me. I mean, I learned a lot using that computer. I spent a lot of time programming various things, games, computer applications. I remember also I had written a program for organizing recipes that I had submitted to a magazine in Greece related to computers. It wasn't featured ultimately in that magazine, but it was a good exercise for me.
Yeah, that's interesting. When I got into computers early as well, one of the first applications that we really looked at in my household was also management of recipes.
Oh, interesting.
That's very interesting to me. I think that was one of the first things that people realized. Like, they have all these very specific recipes written down on note cards and things like that, and they thought, well, this is a great way to store this, right? I can print it. I can easily hand it out to people.
Yeah, I think it's very useful. I mean, right now, if I look at how I manage my recipes today, they're basically pieces of paper bundled together. So
yes.
So even this day, I think I could use something better. But anyway, so yes, so that kicked off my interest in computers. I applied to study at the University of Patras, that they had a new program in computer science at the time. And when I got in, I started studying computer architecture, operating systems. I was very interested at the time also in building computers from different parts and optimizing them for performance. And I think later during my studies, it was a 5-year program. I got in touch with more artificial intelligence. So there was a course I was taking at the time on pattern recognition, and I went to the library and I came across a copy of the Byte magazine that was featuring an article about natural human-computer interfaces.
Yeah.
And so that's where I learned first about automatic speech recognition and speech synthesis.
And just to give people a little visibility into how long you've been thinking about this, when, like you said, you had that copy of that magazine. When was that?
I was 1992, probably.
Oh my goodness.
Almost 30 years ago. Yeah.
Right. So, wait, stop. Did you just say 92 was 30 years ago? The 90s were 15 years ago, my friend. I'm sorry.
Okay.
All right. So you had this magazine. Sorry, 1992. This is a long time ago, and you were looking at human-computer interfaces.
Yeah. So then I got excited about speech recognition and the applications, especially thinking that it could improve accessibility to computers, for people with disabilities, and more generally, better access to computers. So that drew me into taking more courses into artificial intelligence. Actually, as part of that pattern recognition course, I built a prototype phoneme recognition system using feed-forward neural networks. So
Wow.
that was fun. Um, and and then yeah, I think even my master's thesis at that program at the University of Patras was in AI. It had to do with theorem proving. And then I applied to graduate school in the US. I got accepted at Northeastern University
Nice.
and then continued my studies there. But at the time, there was no sponsored research program in AI at Northeastern. At least I wasn't able to get a research assistantship working on that. And it took a while to find something, relating to AI. So I was actually teaching courses on how to use Microsoft Word and Excel and this kind of computer applications.
Nice.
It was interesting.
Nice. So Northeastern's in Boston, right?
Yes.
I am absolutely amazed when you look at MIT and Harvard and Northeastern and a few other schools that are right there. I mean, that is absolutely a hub for the kinds of technology that we're talking about, right? I mean, I know Amazon has some offices there that are specifically focused on a lot of this technology. Are you based there now?
Yeah. I'm based in Boston.
Okay.
I live about 30 miles west of Boston, and at the time when I was studying at Northeastern, there was an opportunity to work in a local company that was actually doing research in speech recognition, and that I was very fortunate to come across that opportunity. Um, so that was BBN Technologies,
Okay.
and I did while I was doing my graduate studies at Northeastern. I worked for about 2 years as a research assistant at BBN, doing research in speech recognition. And that's where I learned most of the things I know on speech recognition and speech technology in general. I was very, lucky to work with pioneers in the field like John McCool and Richard Schwartz. And also, BBN was participating at the time in programs that were sponsored by the government, by DARPA specifically.
Nice.
And I got to submit systems that competed with other participating teams in so-called DARPA evaluations. So you can think of them as benchmarks of speech recognition technology.
Yeah.
And so that was another learning opportunity there. Very, very good opportunity to learn. So worked on speaker adaptation more specifically. Then in around 2004, I also had some opportunity to work with Rohit Prasad, who is now the vice president of Alexa AI at
Yeah.
Amazon.
Yeah. We've had Rohit on here.
Yeah, so Rohit and I worked closely on one of the systems that we submitted for the DARPA EARS program. It was the real-time submission for speech recognition, and we had a lot of fun together. We always look for opportunities to work more closely in the future. But then we work on different teams, different things at BBN. I was focusing for some time on statistical machine translation. Then I worked on speaker recognition and language recognition. And when Rohit moved to Amazon, I think it was 2013. Shortly after that, I followed just to get that opportunity to work again closely with him.
Yeah. So,
And
2013, I joined in 2016. But at that point, Alexa had already been out. So you came over in 2013 with all of this knowledge about conversational AI and a lot of the research and learning that you'd mentioned. But that was way before the first Echo device was available. So what was that early day look like? I mean, obviously it had to be very quiet and kind of hush hush, but what was the work like?
yeah, so actually when I joined the team, before joining, I didn't know what I would work on. It was a very, very secret project.
Right.
And the team was very small. Initially, we were focusing on building one device. It was the Amazon Echo. There was not even, Alexa as a concept at the time. So particularly, we were focusing on improving the wake word detection and speech recognition accuracy on that device.
Okay.
And that was a very challenging problem because we had to deal with far field speech, meaning that it's a distant speech, right? So the
Mhm.
user might be trying to interact with the device from across the room, and then you had to deal with phenomena like reverberation and background noise and music, or background speech, which is even more challenging. And there was no representative publicly available data to use for that kind of problem. So we had to work a lot on signal processing algorithms, on improving robustness of the system, and and we also had to innovate in terms of collecting, uh, devising a methodology to collect representative audio data for building our models, and
So
that was very effective.
if I can dig into that a little bit, so that's interesting. You're looking for data that is basically you're looking for a collection of recordings that are using this kind of distant sound, right, where people are far away from the microphone potentially. Um, and you're saying you guys had to go basically collect that yourselves. What's the process like for something like that?
Well, in this case, we had to basically try to recruit people who would come in a certain place and interact with the device based on some guidance that we provided. We didn't want to give them too strict, guidance on what to say and how to say it, so that it's more like natural speech. Um, and then collect from different devices in different placements in the room and so on. So that's what was amazing about the process was that we moved very quickly, and that was the first instance where I saw Amazon in action, right? Being able to take an idea from a conceptual stage into actual large scale project that we worked on very, very rapidly. So that was a lot of a
Very
learning
cool.
experience.
I would bet that sounds incredibly interesting to me. I have a side question for you, out of just curiosity. You mentioned that early on you were working on echo and wake word detection and that kind of stuff, but that Alexa wasn't really a thing yet. It wasn't part of the project that you were working on. So if you were working on wake word detection, were you working on the words like Echo and Amazon, or were there other wake words that you had played with,
Yeah,
especially when you were doing all that data collection?
we had different candidates, and Echo and Amazon. I think Amazon and Alexa were the top two, candidates at the time. So um, we did, we had user studies. We did things to decide, which one to go with. Ultimately, we decided with Alexa. I think it was the right choice.
Yeah, agreed.
Um, but that was the wake word. I think the concept of Alexa as a um, voice service that enabled natural voice interactions across a range of device and different device types. That really materialized after we launched the Echo device, and we saw the interest from the public.
Got it.
Um, and uh, so after that, after we did that, I started focusing more on other parts of the system, um, specifically on natural language understanding.
Oh, cool.
Uh, and that was useful to have that experience from previous work at BBN on machine translation and other kind of projects. So on natural language understanding, I worked more on the problem of multi-domain understanding. So we had different domains like music and news and shopping and so on. So trying to make sure that we are able to understand customer requests across a variety of those domains and be able to scale functionality that we developed across those domains easily. Um, and I also worked on more data efficient learning techniques in that space. So
Okay.
techniques like active learning to select the data that is most impactful for learning purposes, transfer learning to be able to develop natural language understanding for new skills or new functionalities without requiring a lot of manual data.
Interesting.
Um,
So, can I ask about active learning? That's an interesting concept that I is not something that I've been presented with before. So, is this the concept that you have? Let's say you have 100 entries in your data, and you have some engine, some machine learning, something that's saying these 45 are really useful and these 55 aren't. Is that kind of the concept?
yeah, I think you can imagine if you have a large corpus of annotated data, you can probably identify a subset of that is the a minimal subset that can cover all the different types of phenomena that are of interest to model and be sufficient to achieve good performance. So I
Gotcha.
think the point is that, yeah, it's always true that more data is better, but if you are able to identify what is the most valuable or impactful data, especially if you have a large amount of data to sample from, I think it's very useful so that you don't waste annotation resources on data that doesn't, give you a lot of value in terms of modeling
Cool.
capability.
And then the natural language understanding stuff that you were working on, did that translate's the wrong word, but did you use that across any other languages?
Yeah, actually, we did, and of course, initially we started with English, but then as we expanded to other languages, it was very useful um, to use techniques like statistical machine translation to be able to port um, uh, bootstrap natural language understanding for a new language. For example, if we wanted to bootstrap for German, we could use English to German machine translation system to take the annotated data that we have in English and translate it, create an initial corpus for German, and then build our NLU model on that so that we don't have to wait for new data to come in and label it and so on. So that was an accelerant for porting the system to new languages.
Got it. So in the 7 years you've been here, that sounds like some of the stuff that you worked on early on. What were some of the other focus areas that you had as you were getting into this?
Yeah, there were actually, I was fortunate again to work on a lot of interesting problems so far at Amazon. So besides natural language understanding, I spent some time working with a team on developing our speaker recognition technology,
Oh, okay.
which is now enabling Alexa to provide personalized responses to customers who have enrolled their voice.
Yeah, I see that all the time when I say play my music, and it does, and it knows that it's me and it's my music library, not my wife's or my children. Right? That's great.
Yeah, and sometimes Alexa greets you with your name if you
Mhm.
have enrolled, right? So it's a small thing, but it makes the system a bit more natural to interact with.
Yeah.
The other project I worked on was more in the direction of self-learning. So trying to basically, rather than relying on manually annotated data for all our services, try to improve the accuracy of our machine learning models using customer interactions and feedback that we extract from those interactions. Um, and one particular problem that was interesting to me in that is how do you know whether the customer was satisfied with an action that Alexa took, right? What are the signals that are indicators of um, customer satisfaction or dissatisfaction, and how can you use that to improve the system?
Got it. And
So
so, are you relying on things like sentiment analysis for that, or what are the tools that you use to think about that?
sentiment is one aspect, but there's some easier kind of indicators to identify. For example, if uh, you ask Alexa to do something and Alexa provides a response, and then you barge in to interrupt the response and rephrase your request, that can be an indicator that maybe you want something else, right? And
Interesting.
it doesn't necessarily have to do with the sentiment, but if you can also extract the sentiment of the request, then can be additional information to use.
That makes sense. Cool.
Um, so more recently, I've been working on the problem of selecting what is the best skill to respond to a customer request among thousands of skills that we have in the system.
Right.
And so that's a very interesting and challenging problem because you have to be able to do that um, with skills that are overlapping in functionality. You have to be able to leverage the context around the request, like what was the device doing at that time, what were the device capabilities, what was the preceding customer request and response from Alexa, and use all of that information to find among the thousands of skills which one is the most relevant and they want to provide the best response to the customer.
Right. I mean, it's a good problem to have, right? To have thousands and thousands of skills available to customers. But I imagine that creates a very difficult problem for you because now you have to figure out how to serve the right one at the right time to the right person.
Yeah, exactly. And you don't want the other issue is that customers don't know all of these skills, right? And so, I mean, it would be easier problem if they could reference them by name, right? And they can do that. They can say, Alexa, ask skill name to do something, right?
Right.
But if you have hundreds of thousands of skills, customers typically don't know what's available, or they forget to use the name, and so we wanted to have a system that is more natural and enables the customers to access the functionality they want or get the information they want without having to remember special invocation phrases or skill
Right.
names.
Right. It should be incredibly natural, right? They should be able to say things the way they want. And if that somehow leads them to a skill, then it should.
Exactly.
Yeah. That's great. So are there any other procedures or methodologies that you guys are approaching to think about how to better serve this stuff for customers?
Yeah, I mean, the other problem with this, with the fact that there are so many skills, is that the discoverability, right? So basically, how do we help customers know what Alexa can do for them? What are the skills that can help with their goals? And so, besides, the natural interaction that I mentioned earlier, where customers can just ask for the functionality and we find the relevant skill automatically. The other thing we can do is to proactively make recommendations of skills that may be relevant at the moment, right? So maybe if we can infer what is the customer's latent goal, given the current interaction, can we make a suggestion for a follow-up skill that can satisfy that latent goal? For example, if the customer asks Alexa how long it takes to steep tea, right? Then maybe they're doing that because they want to set a timer. So Alexa could not just respond with the time, maybe can say, okay, yeah, it takes about 5 minutes to steep tea, but also offer proactively to set a timer for that
Yeah,
duration.
that makes sense. So you're kind of inferring what their ultimate goal is, even though that wasn't what they indicated. They just wanted to know how long you should steep tea. But it's clear if you're asking that question, you probably want to steep some tea. And because of that, offering a timer that for that amount of time makes a lot of sense.
Yeah. So we have a system in place that is we're developing to do this. Try to identify those opportunities and basically based on some inference of the latent goals of the customers, and that's also another interesting opportunity for learning from customers' interactions. Because let's say if you make a suggestion and it's not a helpful suggestion, you can learn automatically based on the customer's interaction to suppress it in the future, right? So that you don't always surface the same experience unnecessarily.
That's clever. That's smart. I like that. So I guess the next question is then, like, how are you thinking about customer feedback? How do you take that into account when they're interacting with all of these skills?
Yeah, so there are different forms of feedback. I guess, the one that I mentioned earlier also is more like implicit. So let's say the customer asks for a request and then they don't get what they wanted. So they interrupt Alexa's response and they rephrase the request. So from this pattern of, two back-to-back requests, where one may be a reformulation of the other, we can learn to rewrite certain requests, especially if the second time led to a successful outcome, right? So let's say the one example is if, let's say, the customer was asking to play the ABC song and Alexa didn't know what it was, and then the customer played the wrong song, and then and the customer rephrased the request and it said play the alphabet song. And that was successful because the customer listened to that song until it ended.
Got it.
Then from that sequence of interactions, especially if it's a pattern that is common across different customers, Alexa can infer to automatically rewrite the play ABC song to play the alphabet song,
But
right?
that's based on a larger number of interactions, right? That's not something that would change based on one or two. Because I would imagine, again, being a developer, thinking about those weird edge cases, there's someone
Yeah,
that said play the ABC song, and Alexa wasn't able to do it, and then they said, all right, so instead play AC/DC, right, or some
yeah, right.
other artist or band. You wouldn't want to then map that to the ABC song. I think that might be weird. But you base that on a much larger set of data, I assume.
Correct. Yeah, it's an aggregate form of learning. You're trying to see, what are the gain more confidence in the inferred um, substitution, let's say, that you get from these interactions by looking across customers and across time.
Very cool. So do you find that this is a valuable process to think about this kind of learning? Like how
Yeah.
many misses does it help offset later, I guess?
Well, I mean, so right now this system has been in production for over a year now, and it corrects millions of errors that result from Alexa mishearing or the customer, or from customers,
Wow.
misspeaking their requests, right? And so I think we estimate that about 16% of the defects in Alexa are corrected automatically using this technique.
Wow.
And usually it takes just a few hours to identify a defect, again, if it's a common pattern across customers,
Sure.
and correct it, versus, let's say, weeks that it would take if you had to use the traditional supervised learning techniques.
And I think it's safe to assume this based on the scale we're talking about, but this doesn't require any human intervention, right?
Correct. Yeah, this is fully automatic.
That's amazing.
That's the beauty of it. So you don't have to have a human in the loop to validate the system. And as I mentioned earlier in the example I gave before about the proactive recommendations for skills, even in this case, if let's say Alexa has learned a substitution that seems bad based on negative customer feedback, implicit or explicit, then it can automatically also suppress that using some bandit algorithms.
Interesting.
So there are, again, different ways to automate this learning. On one hand, from learning new kind of substitutions from the customer interactions, and also learning, which ones to suppress or reinforce based on the customer feedback.
Yeah, and I would imagine things trend and change over time too, right? Like just the words that people use and the meanings that they put on those words can change over a period of time. And so it's very possible that all of a sudden you start recognizing new patterns, new requests, new word orders that ultimately lead to these things. And so over a small amount of time, I would imagine, you're able to start accommodating things like new slang words and stuff like that to match what they're actually requesting.
Yeah, I think that's true, and there are opportunities also to learn more interactively from customers as well. So,
Yeah, agreed. No, that's very interesting. I always wonder on machine learning engines like this, whether one person has the power to influence, like if they went out of their way to just repeat a pattern over and over, that would mislead the machine learning, or if a small group of people decided to try to be effective in that way. I think we probably have some safeguards in place for those kinds of mischief as well, but I always wonder about that when I see something that's completely driven by AI machine learning, to be able to say, well, what would it take to influence that, right? No comment needed there. That's just an observation of mine. I always wonder about when I see these kinds of algorithms.
yeah.
So you recently authored a paper for ICAST 2021, and it's on speech emotion recognition. Is that right?
Yeah, that was some work that the team was working on emotion recognition did. It was basically using relying on unsupervised pre-training, using contrastive predictive coding to help build more accurate models for predicting emotion.
All right, so tell me more about that. I'd like to understand that better.
Yeah, I mean, emotion recognition is useful in general as an area for conversational AI. If you can think about, conversational AI agents that are successful interacting with humans, I think they need to be sort of more emotionally aware, or having this so-called, artificial emotional intelligence, right? So in the applications that we discussed so far, a conversational agent could use emotional state of the user to be able to extract information about their sentiments. For example, maybe when they make a request, are they, for example, frustrated, right? Could it be because the agent didn't hear them properly when they're trying to invoke in a previous interaction, or if, let's say, the response that the agent provided in the previous interaction was not accurate or relevant, maybe that caused the frustration. So being able to detect that is very useful. It's also useful to be able to reflect that emotion in providing responses. So, for example, when communicating sad news, that where you would expect a customer to react with a certain type of negative emotion, it's better to use appropriate tone. And especially in the field of open domain conversational AI, as the one that we have in the Alexa Prize competition, where we have the social bots that university teams are developing, and for that program, I can't imagine that you can have an engaging conversation with a social bot for 20 minutes or more if the social bot doesn't have that ability to understand emotion and reflect it properly.
Okay. We actually have a question from the audience, if you don't mind. It's about the Alexa Answers website. They said they spend some time each week on Alexa Answers, and they wondered what the meta learning is on patterns of questions kicked over to answers. Like, what are the mechanisms that make a question land over at the Alexa Answers website, and how do we measure or manage the patterns of answers that we see there?
I think there are lots of the problem with question answering is that there is a very long tail of questions, and it may not be feasible for a system to know the answer to all the questions, right? So the idea behind Alexa Answers is, how do you enable customers to receive answers to their questions at some time, like basically, even if, let's say, the first time Alexa doesn't have the answer, can it automatically do something to make sure that the answer to the customer's question is collected and surfaced at a later time, right? So that's basically a detection pattern, trying to figure out what are the questions that were not that we didn't have answers for, or that we didn't have answers that were satisfying to customers. We have a mechanism, for example, to ask for customer feedback. You may have noticed Alexa sometimes asking, did that answer your question, right? And based on that feedback, Alexa can know which responses were satisfying or not. And then use that data over time to identify what are the areas of opportunity and where some human in the loop could be able to provide answers to cover that space better.
Very cool. All right, so I apologize. I thought that was an interesting question that I wanted to drop in there, but we were talking about the measuring emotional reaction and that kind of stuff. What are some of the bigger challenges you find with measuring customers' emotional reaction and responses?
I think the problem in general with this space is that there isn't a lot of representative labeled data with emotion. And so, again, you need to innovate in terms of developing algorithms that can learn from unlabeled data as much as possible. And the ICAS paper is one example of an approach that does that, right? So the other challenge there is to do with, even if you had, let's say, lots of resources to label data, labeling emotion is kind of subjective. And it's also not very scalable, or may not be feasible for customer privacy reasons. So, sure. So that's where, again, relying more on self-learning techniques, I think, is important. Being able to again, learn from online customer interactions and back propagate those learnings to all the underlying components, including the emotion recognition, to optimize that over time.
All right. So specifically around this emotion recognition, we have a couple of more questions that I'd like to ask. The first one is about well, they say that they're fascinated by speech emotion recognition, and they said they think there's a long way to go with like witty answers and sarcasm. Can you talk about that a little bit? Because I would imagine detecting sarcasm is hard. It's hard for humans, so I would imagine it's probably difficult for computers as well.
Yeah, I don't think we're there yet. I mean, this is very challenging problem, and I think right now the technology is more basic stages where you can detect what we call like activation, like what is the intensity in the emotion, and valence. Is it like a positive sentiment or negative, right? And
Got it.
there may be gradations in between. So to go from that to something more like, say, esoteric, like the sarcasm and wit, I think we have a long way to get there.
Sure. Do you think that there's a pathway there though? Like that's something that certainly is possible. It's just a matter of having the right training data or being able to identify patterns that maybe we don't yet identify.
I think it's possible. I mean, again, if humans can do it, I would expect machines that in the future with more, elaborate training and better algorithms to be able to do it as well. Um, but yeah, it's one of the areas of sort of the holy grail in artificial intelligence to be able to understand uh, human behavior and human
Right.
emotions at a very high degree, including the sarcasm, as you mentioned.
Right. That always seemed to me to be a very challenging problem, sarcasm. So you said something there though that was really interesting to me, which is if a human can do it, I expect a computer will be able to do it eventually. Uh, that's a powerful statement. That's not something that I've ever really considered was a position someone would take, because I think that there are an infinitely large, hard number of problems that humans can do without any effort at all. But I like the deliberate confidence that you have that we can solve these problems. It may take time, but we can do it. That's almost really refreshing to me to hear, because to me, again, not being a machine learning expert by any means, I dabble. It's incredibly encouraging to me to think that someone that is educated and as experienced as you is willing to say, like, yeah, we'll get there. It'll just take time. It takes data. It takes algorithms, but we can do it. I love that.
Yeah, I mean, that's why I work in this field. I mean, if I if I don't have that kind of vision,
That's true. That's
what's the
true. That's
point?
true. Okay, so you're almost 8 years into your tenure at Alexa, and you've obviously seen a lot of what's gone on here. What do you think are the things that have, for at least for you, have changed the most since the early days?
Yeah, it's quite different actually. In the early days, we used to focus on more foundational things, like we were building one device, as we said, the Amazon Echo. Um, it had a small number of skills that we developed internally, and we were trying to make sure the device worked well around those skills and for most users. So the main challenge there was getting the right type of data and learning from it quickly. Whereas now we have Alexa enabled in many languages, lots more customers and data that we can get um, through a lot of different types of devices developed internally and externally.
Yeah.
There are thousands, hundreds of thousands of skills. So it's a much bigger space. And now the challenge is more on scaling our processes, and systems, and being able to learn automatically without relying as much on manual annotation, as we said earlier. Trying to work more, learning directly from customers, um, and also being able to enable in self-service manner, enable our partners and developers to build new devices and develop, highly accurate experiences for customers to interact with low cycle time and high throughput. Um, So the other sort of difference between back then and now is our team has grown in size also, right? Alexa is a much bigger organization than it used to be. It's sometimes more challenging to know what its team is working on within Alexa, right? So how do you communicate effectively, keep in touch with all the work on the ground, and avoid redundant work as much as possible. And how do you enable these new disruptive ideas to happen in production when you have customers who rely on Alexa delivering a consistent, robust experience, right? So that's another
Right.
kind of challenge.
Right. No, agreed. It's one of those things where once you have your software in the world, you have to be able to continue to maintain and run that, but also try to advance it.
Right.
They often say it's you're changing the tire on the car while you're driving it.
Yeah.
Yeah,
Exactly.
that's hard. All right. So one of the things as we head towards the end of this interview, which by the way, this has been fantastic, Spyros. Thank you for joining me today. I like to talk about the future. And one of the things that I'd like to get your thoughts on are when you think about the field of conversational AI, where do you personally see it headed? And what are you most excited about?
Yeah, I mean, it's there's a lot of interesting trends in the field, and some of the most exciting things, of course, have to do with nowadays we have these large pre-trained models that can help the system learn new tasks with very little data. Often we refer to this as few-shot learning or zero-shot learning, right? So you've trained the system on lots of data without explicit labels many times. That's the unsupervised pre-training. And then you present a new task with maybe one or a handful of examples, and you're good to go. That now the system can do a new task. So that's one exciting area. I think it's a fantastic opportunity, and continuing that research is very important. The other areas I can think of is, one has to do with multimodal experiences, so being able to fuse information from different types of sensors and modalities like audio, visual, touch, to create more immersive natural experiences with customers. And we have some work that we are doing on what we call natural turn taking, which enables customers to interact with the system without having to speak the wake word all the time, right? So
Oh,
just
interesting.
you can imagine Alexa being able to not only hear the customers but also see what they're doing, whether they're looking at the screen, uh, to sort of assess the device directedness in their interaction.
Interesting.
Can provide these more natural interactions in the future. Um, Another one is we talked a lot about self-learning earlier. Um, as part of that, I think having more interactive kind of um, teaching with customers is very important to enable that. And we have some effort in that space where customers can actually teach Alexa new concepts, right? So, for example, a customer could say, Alexa, set the living room light to study mode, right? And Alexa could ask, okay, what do you mean by study mode? Can you teach me? And then you can say, well, it's 60% brightness. And from then on, if you reference that study mode or similar expression, Alexa can recall that setting for you without having to explain it again. So again, that space, I think this is a small example, but I think it
Right.
illustrates a bigger space of opportunity where this kind of interactive teaching can take place across customers too.
Very cool.
Um, and then the last one is there is a lot of improvement in computing hardware, and that has enabled some on-the-edge machine learning applications. So I think that's also an interesting trend, especially in terms of lowering latency and enabling privacy-preserving machine learning.
Got it. Very, very good. So a little backstory on me, because you and I have really never had much opportunity to speak before this interview. I graduated with a degree in psychology and then found my way into the world of computer science. And looking back, I feel like a lot of the things that I have an opportunity to interview people about here, machine learning, AI, computer learning, all of this stuff is just so remarkably interesting to me that I wish it had passed in front of my face when I was in college, because I think I would have instantly gravitated towards this. But I live in the world that I am now. So for those people that are watching this or that are interested in potentially joining the Alexa team, maybe they're scientists already somewhere else. You've had a good career, 8 years already at Amazon. What do you do when you're looking for new researchers for your team?
Yeah, it's a good question. I mean, there is a few attributes I look for when recruiting people. So one thing is I like people who are problem solvers, and being able to think on their feet and take a new problem and propose a solution to it. Even taking a problem that has a solution and try to simplify that solution. So that's problem solving skill is important. And aligns with our invent and simplify leadership principle at Amazon. Amazon, we have 14 leadership principles that are relevant and guide our work day to day. Another attribute is what we call the builder mentality, right? So being able to not only be strong on the theory, but also on the practice, and have enough knowledge about computers and how computers operate to be able to quickly optimize your algorithms. And I find that it's very helpful, besides machine learning, to have some background in computer science, especially analysis of algorithms, computer architecture, software design. It helps quite a bit. Other is, being able to dive deep. I like people who have what I call a data obsession, that are not afraid to, spend hours looking at the data, trying to sort of find a needle in a haystack.
Yeah.
What else? It's important to have good communication skills, especially at Amazon, because we use written documents to communicate ideas and also to share progress updates with teams. So that's very important. And finally, the other aspect that I like in people, who I recruit is sort of insistence on higher standards, especially in terms of having the right baselines to run their experiments and compare with. So often it's not good to have a good idea and implement it and run experiments with it, but also making sure that you compare it to the right standard, right? So take the best available baseline at the time, evaluate against that, and then analyze the results to make sure that you have the right conclusions and the right opportunity to go after.
Being a good scientist, right? I like that.
Yeah.
That's very good. All right. Well, Spyros, I want to thank you so much for joining us today. I know, in addition to the paper that we mentioned earlier from ICASP, you also have published a number of other papers and blog posts, and all that stuff can be found at amazon.science, which is our science website. And I know that we're sharing a few of the links here in the chat, so if any of you would like to be able to check some of that stuff out, if you missed any of the links, I think we'll also provide a link to amazon.science here in just a moment. But feel free to visit the website and learn more about the science that drives Alexa, as well as a lot of the other research and initiatives that we're working on at Amazon. So Spyros, I want to thank you so much for being here today. I learned a lot from you, and I hope our audience had an opportunity to learn a few things from you as well.
Thank you. I enjoyed the conversation.
Certainly. So again, thank you guys all for tuning in. You can find Spyros and the rest of the Amazon Science team at amazon.science. And with that, as we sign off, I'm going to leave you with a short video about what it's like to work at Amazon Science. Thank you guys all for tuning in. We'll see you again next week.
One of the things that I love about working for Amazon as a data scientist, I get time to research ideas, come up with proposals, develop solutions, and really innovate in my role.
Hi there, my name is Kaylin Lee. I am a data science manager at Amazon. I lead a team of business intelligence engineers, data engineers, and data scientists, and we provide scientific and analytical solutions to serve Alexa music initiatives.
My name is Konstantinos Papagiannis. I'm an applied scientist and I've worked in the Alexa HML team for almost 2 years now.
My name is Jindy. I'm an applied scientist in Amazon. Now I'm in Prime Video Finance team.
My name is Patrick. I'm a data scientist in Amazon's networking team based here in Sydney.
My name is Julian Pachon, and I am the Director and Chief Scientist for Amazon Last Mile.
Scientists and Amazon owners, the fun part of my job is to turn data-driven evidence into business decision makings. We love trying out new ideas. For example, this could be a new way of slicing the data. It could be a new tool to process the data. It could be another methodology for comparison purposes, or just a whole new business problems to solve.
Customer obsession help us make sure we're focusing on actual customer needs, things that customers would use in their day-to-day lives and that would make their lives better.
We're not limited to the problem we want the project to solve. We also think about how this project can benefit other Amazon team or the open source community.
As a science team, the principle that I value the most is invent and simplify. Our job is to innovate. We need to constantly look for new ways of how to do things. And so we experiment a lot. In the experimentation, we also fail a lot, but we aim to fail fast. And when we do that, then we drive innovation.